But that does remind me. Shaders. So, you may be aware of opening a Steam game nowadays on Linux. You spend
Compiling shaders.
maybe
20 minutes.
20 minutes playing the game, but 4 hours compiling Vulkan shaders before you get to play it. Cool. My game uses OpenGL because I don't feel like writing a Vulkan renderer. It's 2,000 lines of C# just to figure out what graphics card you have and if it's capable of being a graphics card. I think Vulkan 1.4 is going to solve a lot of those problems, but I have to wait for APUs to widely support Vulkan 1.4 consistently before I can do that. So I just don't want to fight with that right now. So I'm doing OpenGL. Besides, I don't need Vulkan. I mean, most Wayland compositors, which at the end of the day is what my game engine is, except it doesn't support Wayland being a compositor. But it does all the compositor things. It renders windows to the screen, it does window management, does all that funny stuff that your compositor does. They're all written in OpenGL. And Xavier Hugel again told me, unless you actually need the performance of Vulkan, which realistically it takes years and lots of practice to write code that is more performant than what OpenGL gives you, for the unforeseeable future, just use OpenGL. It'll be fine. So I'm using OpenGL. And obviously shaders in OpenGL are written in GLSL. But in my game engine, they are not. They are DirectX shaders written in HLSL, because my game engine is a hard fork of MonoGame, which is a spiritual hard fork of XNA Game Studio 4 for the Xbox 360 and Windows Phone. So MonoGame is basically a successor to that. What it does is it adds support for other platforms, like it can do PlayStation, it can do Xbox, it can do desktop, it can do mobile, all that fun stuff. It can do OpenGL and it can do DirectX, but which graphics platform you use depends on what platforms you want to target. And if you're targeting Windows, Mac, Linux, you do OpenGL. That is all you get. However, because of the build, or the way assets work in MonoGame, by extension my game engine, because it's a hard fork, MonoGame uses something called the MonoGame content pipeline, where you create this separate project that's separate from your code, and you run this little tool, and it goes through and it finds all your textures and it converts them to MonoGame's format, with some platform-specific metadata to tell it how to load it. It goes through all your audio, does the same thing. Basically, it packs all of your source assets into a friendly format for the game engine in this case. And shaders are no exception. You write them in HLSL because that's what you wrote them in XNA Game Studio 4. So it's the same syntax. But what it does is it transpiles them to GLSL. Now, if you're a graphics programmer, you might be thinking it uses SPIRV to do that. No. SPIRV didn't exist back then. Because MonoGame started development in like 2007, 2008, I want to say. Something around then. And SPIRV just didn't exist. So it uses something else. It used something called Mojo shader to do the transpilation. But in order to do the transpilation, you need to compile it first to DirectX, which requires the D3D compiler, which requires Windows. I'm on Linux. I don't have Windows. So, here's how you're supposed to do it as per MonoGame's official documentation. First, install Wine. Don't use Bottles, because Bottles is going to give you a nightmare when you set this up. Sorry, Skelly. I would love to use Bottles for this, but no. So you install base Wine. Then you set up a Wine prefix. And you're supposed to run this random shell script that some guy wrote. And I looked at the code. I've audited it, so I know it's safe. But what it does is it sets up the Wine prefix. Great. And it goes and downloads a random build of Firefox for Windows, extracts it, pulls the D3D compiler from that, puts it in System32 in the Wine prefix. That's step one. Next, it downloads a random version of .NET and installs it into System32. And that's so that you can run .NET code. And then it downloads MACB, which I already have installed for Linux, but the Windows version, and puts it in System32. That's what the script does. And you're supposed to run that, and then it will set an environment variable pointing at the wine prefix that MonoGame knows to look for, so that when you compile your game, it will go, okay, I'm on Linux, I need wine, here's the wine prefix, I'm going to tell wine to execute MACP and compile these shaders. It'll do it in Windows world, and then the shaders will come back in the friendly format that MonoGame expects. But this requires wine. Now, this is great on Arch, where you have the latest version of wine available. It's also great if you're a human, and you're able to click through the graphical installation of Mono and stuff like that that wine does the first time you boot it. Now, like I said earlier, a CI/CD build pipeline is not a human. There is no graphical interface for it to click on, and it cannot click on those things. So, I ended up needing to create my own image of the .NET SDK in Docker, and I basically did what the script did. So I installed wine into the container. Then I put the random build of Firefox into the container in the right spot. Then I put the random build of .NET framework in the right spot. And then I set up everything so that when MonoGame goes and requests wine to do its thing, it just uses the container, and as far as the container is aware, when you boot into it, you actually get a Windows command prompt instead of a Linux shell. And then it's super sketchy, but it works, and that is what is called the socially distant build environment for Linux. It's a Docker image you can just use. It has everything you need to compile socially distant, and it's super sketchy. But there's a problem with that. If you
we haven't hit the problems yet. Okay.
Okay. That was shaders.
Right.
But this is why I need Windows, specifically, and not wine. Because if you try to build the game for Windows in this build environment on Linux, it'll compile the shaders fine. But there's something else the game has. It has game scripts, written in a custom programming language I wrote called SDSH, which by the name implying is very similar to Bash, because SDSH stands for Socially Distant Shell. It is the in-game command shell, but used as a scripting language for the game, so for missions and stuff like that. Because I like Bash, and I don't care what anyone says about Bash syntax. I find it easy and declarative for what I need it to do in the game. So what I do is, after compiling shaders and stuff like that, and compiling the base game, I have the build system go and ask the game itself to validate all of the mission scripts and everything for syntax errors, so that I can get compile time errors if I screw up a command or syntax. Problem is, I'm doing this through MS Build, because it's .NET, and if you build a Windows self-contained application and try to use that on Linux as an MS build task, despite the fact that this is a .NET assembly, and so it should be universal and not rely on Windows, it'll complain at you because the kernel does not know how to open the library, and .NET doesn't know what to do with it. So you cannot actually compile socially distant for Windows on Linux. And that is how I'm now a customer of AWS. Because now, I could do this the home lab way of just downloading Windows 11 and creating or registering it as a Windows build runner for GitLab, and then tell the Windows build jobs to run on that Windows 11. That'll work, and I did it as a proof of concept to make sure that it works. But if you read the Windows EULA, you're actually not allowed to do that.
Okay.
Because Windows 11, Windows 10, all that, those are client builds of Windows. And client builds are not allowed to be used if you're exclusively using them for remote access. Or automated access. And in fact, if you have Windows 11 Pro, you can set it up as a remote desktop server, but if you are logged in at your desk on that computer, That's the remote desktop server.
Mm-hmm.
And say someone else in your house goes and connects to it. It'll log you out because only one user is allowed to be using it at a time. You can either use it remotely or use it not remotely, like locally at the desk. That's in the license agreement. There's no way around that. And Windows Home, you can't even use remote desktop server on there. So, you're really not supposed to use Windows client builds for remote and automated usage like this. And a CI pipeline falls under that. So you need to use Windows Server. Now, Windows Server is licensed per core. So, it already costs $1,000. I have 4-core processor in that machine. Now, I might limit the VM to only use 1 or 2 cores. That would save me $2,000. You'd think, but no, that's not how it works. Not only is it licensed per core, but it is licensed for each core it could theoretically run on. So if you run a VM of Windows Server and you only give it 2 cores and you pin the cores that it only ever touches those 2 cores, no. If you have a 64-core processor, you got to pay for 64 cores. Simple as that. However, AWS... Okay, no. Backtrack a little.
Okay.
I thought, okay, I use Vultr for most of my VPS stuff because they're Canadian and they're local. They have a Canadian data center. And they're relatively cheap. They're relatively nice. The UI is easy for me to use. And they're Windows Server boxes. I believe for 1 gigabyte of RAM and like 2 vCPUs, it's $24 a month. Don't quote me on that.
Alrighty.
It's a little brutal.
Yeah.
And I only need this server to turn on whenever I need to do a build job. So, I thought maybe I could turn the server off and save money when it's not being used. And just write a script to turn it on when I need it. No, it bills you even if the server's turned off because the resources are allocated.
Sure.
And the storage is allocated. That costs money.
Yeah, no,
so AWS, they bill by the minute instead of monthly. So Windows Server is billed by a minute with EC2, and it is significantly cheaper for this for this use case at least. So, I, with the help of my friend Zaprit, I'm going to shout him out. He does AWS stuff for a living, or at least he used to, so he knows what he's doing. He was helping me through the archaic user interface that is the AWS console, setting up all the instances and stuff like that. And I imaged it with Windows Server Core. So I'm thinking this is Windows Server. It's an automated build runner. I don't need a GUI. I just need command line. Let me SSH in and do what I need to do. That's not what Windows Server Core is. Okay. Windows Server Core is a GUI that only opens command prompt.
What?
So you remote desktop into it and you get a command prompt. And it's PowerShell, which is my worst enemy. I hate PowerShell. I'm not going to rant about PowerShell, but I hate it. I will rant about other stuff to do with Windows. So you log in, and I have a simple task. I need to download GitLab from GitLab's website. I need to put it in a folder. I need to install Docker. And I need to tell GitLab Runner to use Docker.
Right.
And I need to install SSH. That's all I need to do. There's no web browser. None. Not Edge, not IE, none. There's no web browser. Now this is a problem. Who's the maintainer of curl again? What's his name? He might get a kick out of this.
Daniel Stenberg.
Yeah, Daniel Stenberg. You're gonna get a kick out of this if you're listening. On Windows PowerShell, on Windows Server Core, you go to download a file. You have to use curl or wget. There's both. You put in the URL, and it goes and downloads. Except, no, it doesn't, because it pops up big red alert saying Internet Explorer is not available. They aliased curl and wget to invoke web request, which is a PowerShell commandlet. And that behind the scenes uses Internet Explorer.
Okay.
Which is not installed because it's Windows Server Core, and you're not supposed to have Internet Explorer on there. So curl doesn't work.
Okay.
Because it's lying. It's not actual curl. So, I thought, okay, well, I'll destroy this server because this clearly is going to be painful, and I'll go grab regular Windows Server. That way I have a desktop, I have Microsoft Edge, I can do all that stuff and just download things the way you would on Windows.
Sure.
And I set everything up, I get everything working, and then I look up online how to convert a server install to Server Core. Because you used to be able to do that in Windows Server 2019, I believe. Not in Server 2022. They removed that functionality. You cannot convert the install back and forth. If you pick the wrong one, congrats, you have to re-image the server from scratch.
Right.
So I did all this setup, get everything working, and I find out, oh crap, I have this desktop environment running that's taking up resources, an obnoxious amount of resources, and I can't get rid of it. So I have to start over. That was painful. But now I can do Windows builds.